We'll start with the last part of hydrostatics, which is mixing fluids. Okay, so you need to take this down to start off with. This is the formula that you're going to use for today, and I suppose for the rest of this particular aspect of the topic. There is a little bit to do with the total volume in a moment, and that varies throughout the question, but what's on the board here is quite important for you. So first off, just remember that density is mass divided by volume, and that's normally written as P as M over V. Now, when we mix two substances together, because that's what we'll be doing, mixing two substances, two liquids or two gases, the total density will be the total mass divided by the total volume. So compound density or total density is the mass of the first plus the mass of the second divided by the volume of the first plus the volume of the second. Total mass divided by total volume. Now, if we go back to that formula, P is equal to M over V, I'm going to cross multiply, get M is equal to PV or rho V, so mass is equal to density by volume. And what I'm going to do then is instead of M1, I'm going to have density by volume for the first one in place of that, and instead of M2, I'm going to have density by volume in place of that. And that's the formula we're going to need. Now, you might take that down, it's quite important. And you might also have notation there. The P1 is the density of the first object, the V1 volume of the first object, P2 and V2 density and volume of the second object or substance, and underneath the line I have V1 plus V2 there. Really that's just the total volume after mixing takes place. And that's really important. It's the total volume after mixing takes place. And we'll see later when we deal with contractions or expansions that the total volume won't be V1 and V2, it'll be something different. But right now, V1 plus V2 is what I want you to take note of. Okay, one other part to this. So that's our formula. And if you remember, we had a thing called relative density, given the symbol S. That's equal to the actual density divided by 1,000. So if I take the formula on the left and divide both sides by 1,000, the P total divided by 1,000 becomes the total relative density, or the total relative specific gravity even. The P1 and the P2 then will become relative densities for the first and the second object. So the formula there on the left hand side on the bottom is another formula you may need to take down. Okay. Once you have that down, we need to have a look at an example question, but there's a particular layout I like for these questions. I always start off with a table. So the table will have the following. On the left, we'll have the mass, the volume, and the density, and on the top, substance A, substance B, and then the total. So then that's in blue. In the center section and in grey, light grey and darker grey, we'd have the mass of A, the mass of B, or the total mass of the mixture would go in those relative positions. Volume of A, B, and the total volume would go in those positions, and the density of A, density of B, and density of mixture would go in those positions. Now it may be like that, or if we were dealing with relative density, we would just change the last row to something that looks a little bit like that. Okay, so let me show you how it's going to work. So you guys will take a look at question 1.7b. We'll read it out there. And I'm going to fill in my table. We know that the volume of B is equal to 6. We don't know the volume of A, we're looking for it, so we just call it V, which means then that the total volume of the mixture is V plus 6. And what we know is the relative density of A is 1 because it's water, the relative density of B is 1.04, and the relative density of the mixture is 1.03. So we've read through the question, we've taken the information, we've filled it in to the table. And this is really useful because it will help you organize your work. It's one of the most important things in solving these questions. Make sure you draw the table, make sure you fill it in, given your values. Now what I'm going to do is plug that into the formula that we previously had. And all you then need to do is solve for V. So, top left hand corner, The relative density of the mixture is S1V1 plus S2V2. That's relative density by volume for the first plus relative density by volume for the second, all over the total volume. On the right hand side of that, we've it subbed in. I then cross multiply by V plus 6. That brings me to the line with the first set of arrows on it. And like I said, all we do is solve for V. V works out as 2. Everything is in SI units. So our answer there is in SI units as well, which is 2L. Okay, it's your turn now, lads. I'll put a few questions on the board and I'll get you working on those.